Hello, this is Harini, and thank you so much for Emmet for giving this opportunity to explain about the microwave oven simulator project using Picsimlab and MP Lab into IDE. So we are going to discuss about the microwave oven and its objectives, requirements, tools, and simulation cases, and simulation and conclusion. So coming to the introduction of the microwave oven have become an indissoluble part of our daily lives, offering the convenience of rapidly heating or cooking our food. They seemingly straightforward kitchen appliances, however, house a world of innovative technology and engineering beneath their sleek exteriors. In this report, we embark on a journey to the inner working of microwave ovens, exploring their operation through a project realized with the aid of Picsimlab. So the modes of the microwave ovens are four types: micro mode, grill mode, convection mode, and start mode. Coming to micro mode, we can cook food in a traditional way, which uses power of 900 watt. Maximum time is 60 minutes. Whereas in grill mode, we can cook meat and bread. Whereas in convection mode, oven the we can oven it to preheat for particular temperature. It takes 3 minutes to preheat. So the main objective of the project is to simulate the behavior of a microwave oven using Picsimlab and MPLab IDE. So the learning goals include gain insights into microcontroller programming, simulation techniques, real-world application of the embedded systems. So the requirements of the project are MPLab IDE, XC8 compiler, Picsimlab PIC16F8778, 16x4 CLCD, tactile switch, MKP, timer 2. Let's discuss about embedded systems. An embedded system is a microprocessor-based computer hardware system with software that is designed to perform a dedicated function. The categories of the embedded systems are: it can stand alone system, and it is a real-time system, it is a networked system, and it's a mobile system. Embedded system can act like a microcontroller and microprocessor. It is an integrated circuit which is being programmed for a specific task with the design restrictions such as memory size and peripheral function. So microprocessor is a computer processor where data processing logic and control is included in single IC. So let's start discussing about tools which we are going to use in the project. MPLab into IDE. MPLab Integrated Development Environment is an expandable, highly configured software program that incorporates powerful tools to help us discover, configure, develop, debug, and qualify embedded designs for most of our microcontrollers and digital signal controllers. And coming to the Picsimlab, it is a real-time emulator for PIC and Arduino. Picsimlab is an emulator of development boards with integrated MPLab X debugger. Picsimlab supports some Pixim microcontrollers. And here is the architecture of the Picsimlab. Here we can see the block diagram of the Picsimlab, which is having general purpose input output and I2C and a temperature sensor of LM35, an analog to digital converter, and CLD, and a matrix keypad, and SSD, and also a digital keypad, and also a buzzer, and with an LEDs and RS232. All the components are, we can see here. So this is the CLCD and this is the buzzer, And here we can see the digital keypad. And so we can see all the components like matrix keypad and a buzzer and a CLCD and all the temperature sensors and all. And this is the buzzer which gives the output. And CLCD is a character liquid crystal display with 16x2 display and 16x4 display. Communication modes are 4-bit mode and 8-bit mode. And matrix keypad, when more number of inputs are required and still want to control inputs, that at that particular time we use a matrix keypad. These are most used in the telephones, calculators and lockers. And interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller in which an internal or external device requests MPU or MCU to stop processing. They acknowledge the request and attends the request. Coming to timers and counters are important applications in embedded system to calculate delay and measure time. It's a software designed to count time intervals between events. It's the register length. It denotes the up or down count. Scaling may be pre-scalar or post-scalar. And here we can see the simulation cases of power on and modes. Here in the CLCD we can clearly see that when the power is on, how the Picsimlab looks. In Picsimlab, how the CLCD looks. And when we switch it on to the modes, it will clearly show the all 4 different types of modes which we discussed before of micro, grill, convention and start. Whereas micro mode will take more than 60 minutes and grill mode will take more. Whereas grill mode will take more than 60 minutes to cook meat and bread items, and convention mode is to just cook normal items or to just heat the food items. For it will take 3 minutes. And this is the start and time up. And it is clearly visible that it is the start mode, and this is the time up mode, and it is a final stage. I'll go to the simulation now. And this is the code in MPLab. And so here we have initialized the timer. And this is the main function. When key is equals to 1, it is a micro mode. When key is equal to 2, it is a grill mode. And when key is equal to 3, it is a conventional mode. When key is equals to 4, it is a start mode. For the start mode, this time is set up as 30 seconds. For the micro mode and the grill mode, we can set the timer as our wish. This is the entire code. In Picsimlab, we'll see how it is going to work. This is the overall view of the code. We started writing using conditional statements. So we will debug the program once. Now the code is getting dumped into the Picsimlab. And as we discussed before, we got all the 4 modes like micro and grill and convection and start. I'll go for micro first. So we are pressing the key 1 in a keypad matrix. And here, as we discussed before, the power is 900 watt. We can set the timer as our wish. As we discussed before, only for start mode, we have to set the timer for 30 seconds. And here I am going to set the timer for 20 seconds. So after 20 seconds, the food will get cooked and we'll get a buzzer sound. As I discussed before, after 20 seconds, we'll get a buzzer sound and the food will get prepared. Let's see for the grill. Here also we can set timer as our wish. So I'm going to set timer for 30 seconds. So because we use meat and bread products, it requires more time to cook. So after 30 seconds, we will get a buzzer sound indicating that the food has been cooked. And we can clearly see how the timer is running down. And through the glass door outside, we can see what is happening inside. So as after 30 seconds, it produced a buzzer sound. Now let's see in convection mode also, where it can be very fast, where the process will get very fast. So we should set the temperature. And right now I'm setting the temperature for 25, where it preheats at 25. For 18 seconds. It asked us to set up the time. So I'm going to set it for 20 seconds. So until unless we set the time and we click the OK button, it won't accept. Before it got preheated, now it will get cooked. As it will take time to preheat and cook, it is a long process. But it is the best process, because the food will get cooked very properly and regularly. So after 20 seconds, we got a buzzer sound. So food is ready. We'll go for next. Let's discuss about the start mode, where we discussed before that time is already set by 30 seconds. So clearly you can see that just by clicking 4, we got a timer pop-up window with the 30 seconds. After 30 seconds, automatically we will get a buzzer sound. After 30 seconds, automatically the buzzer sound. let's go to the conclusion. So this is how the microwave oven project works. So in this project specifically, we have learned about microwave oven and embedded systems and microcontrollers. In this internship, we have already learned about introduction to C, conditional loops and operators, array and pointers, functions and strings. And after introduction to the C language was done, we started with an embedded systems and microcontrollers, and we started how to initialize and download the MPLab IDE, XCB and Picsimlab softwares into our laptops with the proper functionalities and requirements and specifications. Later we got to know about the various peripherals of PIC16F877A, how we have to use it, and how the buzzer will work, and how the matrix keypad will work, and also about the CLCD and each and every part of the board. Virtually we have learned it. Later we have interfaced the various peripherals of the Picsimlab, and we started writing code in a MPLab IDE using with the C language conditional statements, as we discussed in the starting stage of our internship program. Through that, we have written a code with all different modes, especially in this microwave project, with 4 modes of micro mode, gray mode, convocation mode, and start mode. Then we started interfacing the program which we have written in MPLab IDE into Picsimlab. Then we started debugging the particular code, and we heard the buzzer sound as we saw. And by setting the timer properly, that is how we learned about the microwave oven in this internship very clearly. And we have given multiple quizzes in between, like every weekly test we used to attend with the introduction. First week we had written our quiz regarding C language. Later we have written our regarding embedded systems and microcontrollers. We got a clear knowledge about embedded systems and microcontroller. Later we had a quiz regarding the software and how the things are going to work in the PIC16F877A and Picsimlab and MPLab IDE also. At last we used to give a Disha test. 2 Disha tests we have given in this internship, and we are thanking Emotex for giving this wonderful opportunity to take us as a part of their internship and providing knowledge for free. And so I would like to appreciate their effort, and I am so happy that I am a part of the internship in 2023 batch. Thank you so much.